our session around redefining security for the cloud AI era. Before I move forward, show of hands, how many of you have started experimenting or are already deploying production Gen AI applications for your customers today? Quite a few of you. How many of you have figured out or are in the process of implementing security controls or a security program specific to Gen AI use? Quite a few. So good news, you're in the right place. We'll talk a little bit about how the landscape's changed in terms of how security needs to be adopted and implemented with these applications that leverage large language models. My name is Samir. I'm a principal product manager at CrowdStrike. I work with our customers to build security products that enable them to use and secure cloud workloads on AWS. Today we'll start off with talking a little bit about the adoption trends that we've seen with AI applications and use of Gen AI models themselves, some of the security challenges associated to them, and then walk through how we think you can leverage security tooling and best practices to implement security while these applications are being built, configure, monitor, and implement strategies to remediate misconfigurations on AI cloud services, and wrap up with understanding some best practices and mitigation strategies in terms of what you can do if you're not there yet. So let's start with some of the adoption trends that we've seen. Now, unsurprisingly, what we've noticed is over 60% of customers have started using Gen AI apps or some sort of large language model-based applications within their environment. Now, this is because of the enormous amount of use cases that they're trying to figure out and use it for. Everything from chatbots to support customer support, marketing and sales apps, travel agent apps. The use cases are phenomenal. Now, the second part of this, though, which is interesting, is over 50% don't have appropriate security policies or haven't started implementing security policies for these Gen AI applications. And while the adoption's been crazy over the past year, it's just begun. Given the productivity gains that customers are seeing and the customer experiences that these provide, the adoption curve is just going to start increasing exponentially over the next 3 years. And so some of the projections include over $300 billion of software spend on AI services and softwares themselves. Now, given that change in adoption trends and the pace at which it's going, what are some of the security considerations when using these applications? Now, let's start off first with AI model safety. Now, when customers build AI systems, they want to prioritize safety, ensure transparency, fairness, and robustness at every step of that customer experience. This means the models themselves need to be free from unintended biases and withstand adversarial attacks and also ensure that they're maintaining ethical and legal standards that are required from emerging regulatory frameworks. This means there's a need for rigorous testing, monitoring, and adding things like guardrails and other risk mitigation strategies for the model itself. Now, as you build these models themselves, there's a lot of fine-tuned data that customers are starting to use to make the model relevant to what they want to give their customers. Now, this is internal proprietary data, and what we want to do is ensure governance of that data and ensure that access controls are implemented appropriately. Now, of course, all of this runs somewhere. The models themselves are containerized if you're building them yourselves, and it's running on some sort of compute. And there's additional services that complement the application themselves. So how do you protect the infrastructure, whether you're running it in the cloud or running it with things like EKS anywhere? How do you ensure the infrastructure itself is secure from adversaries? And the last bit is privacy concerns. With models now being tailored with custom data and built on data that might have been coming in from surveys or other means, what this means for developers and security teams is they now have to consider things like how do they anonymize data, how do they address GDPR concerns, how do they minimize data exposure, how do you ensure access controls are implemented for developers so they don't have access to customer data. And emerging themes are more regulations and frameworks to ensure privacy of customer data. And so how do you implement those controls becomes a big concern. Now, beyond just those security considerations, we have to think about how Gen AI is being adopted. Now, usually how this has happened is without any formal adoption process, which means developers or users are starting to use them within their own devices or on laptops. They might be uploading data that might be sensitive. They might be using data from the LLMs that might not be accurate. And so this creates a risk that's outside of established security controls and governance that you already have in place. And given some of these new challenges that we talked about, the standard protocols and checks we have in place today don't necessarily matter or are relevant for these specific types of applications. Now let's talk a little bit about a real-world vulnerability and what it means for customers. Now, a few months back, there was a vulnerability that was discovered on an LLM application, not the model itself, but the interaction with the model and the way the input-output responses of the model was handled allowed attackers to exploit this specific vulnerability, which was an authentication bypass vulnerability, and start probing for passwords, tokens, and access to repositories. Once they had those keys, they were able to move laterally and pull down sensitive information from a vector database. Now, what this means is, while you might think the biggest risk is just the foundational model itself, you do need to think about all of the components that make up the application. So how do we start? How do we start to break down what are the security-specific responsibilities we have? We have a neat framework called the shared responsibility model, which we're all familiar with. Now, on the left, I have the three components that make up the AI application. So when I'm talking about the AI platform, it includes things like the safety of the foundational model itself, the accountability, the tuning of it, the infrastructure, and data governance. The AI application means everything from the plugins involved, the data connections, as well as the infrastructure and any code that's associated with the application. And finally, when I'm talking about AI data and use, data access and governance, administration and controls, identity and access management, all of these are other things you need to consider. So now, depending on how you choose to build your application, you have three different modes that you can choose to build it on. You can either start by building your own model, which is your BYOM use case. And what that means is the responsibility for the customer extends right from ensuring security from the AI platform layer up to the data and use layer. And that responsibility shrinks as you move, right? As you'd imagine, when I'm talking about things like AI platform as a service, you're thinking about using things like AWS Bedrock, but you might choose to use your own model. So the infrastructure could be secured, but the models you're building need to be secured themselves. And finally, AI SaaS services are things like where you have just an API that you use, you interact with the API, and what that means is ultimately you're only responsible for the data and use portion of the security model. Now, extending that, how is the application actually built? We walked through this a little bit, but we start off with the infrastructure, which is the platform, and the compute and the model. The data that you either interact with or you train the model with. The foundational model, of course, which is part of the application's core. And of course, the user experience that's built on top. Now, that's the typical 4 layers that you might see as part of the tech stack. Now, when you look at this, it looks like a typical web application, but the only difference being it's based off of a foundational model. So how do you start implementing security, and what do you need to look for? Thankfully, our friends at OWASP have a framework that they've published recently, which guides for the top 10 things to look for within LLM applications in terms of risks. Now, I'm not going to overburden you by explaining every single one, but let's go through a few of these. The first set is concentrated more on input and output response security. What that means is ensuring that users are not gaming the model to either take advantage of exfiltrating data or running some sort of arbitrary code execution. Insecure output handling is what if the LLM itself emits something that's not specifically accurate, and that could lead to things like CSRF sort of attacks. There's of course the security of the data itself, whether that's poisoning the data, which means you're adding data that could influence and bias the model a certain way or make it inaccurate, and of course not providing or disclosing sensitive information from that data. Now, as these applications are built, whether that's the model itself or other components, the supply chain becomes a huge factor. We walk through examples, but typically people take foundational models either from a Hugging Face or frameworks from other resources and build off of there. So supply chain vulnerabilities are key in terms of assessing. Other things include things like model theft, where the LLM and the model itself might be stolen if effective controls are not in place. Now let's figure out then how we take those OWASP top 10 and lay it on an application that might be built on AWS. Now this is a typical sort of application. It's a web app built with Amplify. Authentication with user authentication and management with Cognito, leverages Bedrock, and of course is monitoring and identity and access management and databases to pull data from. Let's first start with the front-end components. Now, you might see there are multiple things that you want to look for. Start with what the user interacts with. This is where they're given a user interface and they're asked, what do you want to do? This is where things like broken access control mechanisms means users that might not have access to the data get access to the data via the specific user interface. Prompt injection techniques, which I will overlay here. And of course, insecure output handling. So a lot of these OWASP top 10 specific vulnerabilities, as well as additional sort of controls, are needed just at that particular layer. Now moving on, moving on, if you look at the specific components that are part of the management capabilities, these are things like identity and access control misconfigurations, which means it's either overly privileged or there's too many users that have access with admin privileges. There's data and integrity failures. And of course, some of our OWASP top 10 for the model theft is also in there, because if you are building your own model and running it on Bedrock, you want to make sure there's access controls there as well. Cool. So we spoke a little bit about how an application looks like. How is it actually built? Who are the users? How is it transitioning from just some sort of a file into an actual application? Now, there's multiple people involved, as you can imagine. Starts off with a developer who's probably building the full stack. There's the platform admin that controls the cloud service and the cloud platform itself. There's also the ML and data engineers that help build the models. And of course, there are folks from governance and risk controls, and of course, a model approver as well. So anything you build has to make sure that all of these users understand the risks themselves and start with implementing security controls from the developer to ensure security is baked in, and provide visibility for the governance folks to ensure they can provide capabilities of audit and transparency, which is now becoming a big requirement. So let's then start off with how we secure AI applications during development. Now, there's 3 typical stages in terms of securing AI models. So I'll walk through all 3 and we'll concentrate on the first one. First off, you want to secure AI during development. You want to manage the posture of the application and the services that it runs on. And of course, monitor threats against it. So let's start with the AI development piece, like I mentioned. And I'm going to focus first on an example where you're building your own models. Typically, how this is done is a Git repository is a source of truth for all of your code and controls. And some of the frameworks that I used are things like TensorFlow, MXNet, and PyTorch in terms of building the model itself. Typically, developers, like I mentioned, not only pull those specific libraries, but they're building custom code and maybe adding additional third-party libraries as well. And of course, foundational models, if you start off there, you're also pulling from third-party and fine-tuning it. And there's also access to data lakes or on-premises data stores via APIs. The typical way custom models are built is you push it into a Git repo, we monitor it, and as soon as there's a change, code build goes into action, pushes the 2 specific containers for the application itself and the inference container into ECR. And of course, you can then run it on EKS and expose it via SageMaker's endpoints. Now, the interesting part is we took a look at all of the frameworks and formats available today. There's many, probably like 6 or 7 that's used to build these models. Taking a look at Hugging Face, when looking at over 1.5 million large language models, over 60% of these models were vulnerable. Which means if you're going and pulling down any container and using it on your application, there's possibilities that there was insecure code involved. Now, the distribution is typically NumPy and PyTorch is what I believe is the highest. And most of these are, of course, insecure. So where do these vulnerabilities emanate from? In the application itself. Now, I mentioned these come from container images, which are pre-configured with the models. You might have virtual machines and templates that's OS-specific vulnerabilities as well. Third-party libraries as you build the application, and any third-party data that's used for training and the data sets involved. Mapping back to some of the specific risks that we spoke about, this is where supply chain risks start. when you're adding these libraries, when you're pulling down models. We've also found that some of these models have embedded malware and also prompt injection sort of code baked into them. And given some of the data sets, depending on what you use, you can poison the model as well, given the wrong data. So what can you do to mitigate these risks? Ensure that you're identifying and securing the supply chain. You want to secure the model pipeline, and you want to threat model and do code analysis as well. How can CrowdStrike help? Now, typically, like I mentioned, most of these applications are built inside of a Git repo. Whenever there is a new change to a Git commit, it's usually two components that go with the application. One is the infrastructure as code template, which defines all of the cloud security, cloud services that you use. And of course, there's the container that gets pushed, which is both the ML inference container and the app container that we talked about. Now, as soon as these get pushed, a new version of the app is built using code build. Now, with Falcon pre-runtime scanning, as soon as these get baked into ECR, we're able to pull down those images and scan them for vulnerabilities. Now, we spoke a little bit about the frameworks and extensions previously. Why would we talk about it? The first thing we're now doing to ensure security for applications is to scan for AI and ML framework specific vulnerabilities and expose them to customers so they know that there are either risks involved or malware involved or secrets or misconfigurations on those containers. Now, the entire life cycle, of course, is once the specific container gets scanned and passes the checks that you have in place through a policy, it then gets pushed into EKS, where we have monitoring in place with both agentless and agent-based configuration and security. So what can container image scanning do? Of course, it scans container images. Second thing is it does dynamic container analysis. What this means is we pull down the container and we let it run for some time. What it exposes is behavioral detections on the container. Now, static scanning only can go so far, but when we do dynamic container analysis, we might start seeing interesting things and then ensure that the container should not be deployed. So of course, things like serverless functions, which now have containers themselves, we can scan for those. And of course, we have APIs to ensure that virtual machine army images can be scanned as well. Now, that's the security of the pipeline and the application code. Now, these have to run somewhere, and we spoke a little bit about EKS, but there's also complementary services. So how do you ensure that you're enhancing the security that's already built into all of these cloud services? Let's start with how to build a program to implement secure controls. Now, the first thing is developing AI governance in culture. Now, what that means is helping users, whether that's internal or external users, giving them an acceptable use policy that ensures they understand where AI can and should be used. What that does is it builds awareness both about usage policies as well as the risks associated with these applications. And of course, this is not a one-time thing. What you want to do is continuously communicate and update them as the landscape changes. Now, the second bit, of course, is ensuring access controls and data protection. We spoke a little bit about this, but ultimately, an LLM is providing customers with information that either is proprietary or customers or developers have access to data that might be sensitive. So how do you ensure things like data access policies and data boundaries are prevalent within the environment? How do you ensure DLP is monitoring for these capabilities? And ensure that there's robust protection in terms of any leakage associated with data itself. And if there is no route that is secure, provide a safe alternative. Vet out other AI platforms and tools, and ensure only authorized users have access from, of course, a secure device. Now, the first thing then you want to do in terms of implementing controls is to gain visibility into cloud services and how they're configured. With CrowdStrike, we now have the ability to secure AI cloud services and the configurations associated to them. We start off by giving full visibility into things like Amazon SageMaker and Bedrock and any configurations associated to them. This means finding vulnerabilities, misconfigurations, exposure, and access to sensitive data. We can also find supply chain risks, like I mentioned, with integrated scanning of ECR repositories. And of course, with EKS and ECS, we also understand if those specific endpoints are exposed. Now, these models typically run in some sort of a containerized environment, like I mentioned. With Falcon Cloud Security, you also get runtime protection of the AI models themselves. What that means is we now support the ability for specific runtime telemetry and detections for AI-specific behaviors. Now, this is something we're researching and coming up with, but it should be available soon. Now, the second part of it is we did scan for these images when we were deploying them. But how about when you start seeing zero-day vulnerabilities? What do you do to address things like a new zero-day is discovered and try to find out whether a specific vulnerability exists in the environment? Now, with runtime model scanning, what we do is ensure that we have an understanding of where an image was deployed, whether it was scanned or not. And as soon as we see that a package was scanned, we have metadata associated with it. And tomorrow, if that specific package was found to be vulnerable, we can quickly set a detection to say that that specific vulnerability exists in the environment, easing detection for security teams. And finally, all of this requires context in both what is happening on the runtime side as well as how the cloud is configured as well. And so blending those two gives customers and security teams better information on how to address these specific risks. Finally, we have the ability for customers to get access to a unified AI posture screen, which gives you all the information you need, starting from where are my AI models deployed? How many of them have sensors running on them? Do they have vulnerabilities? Are they matching compliance frameworks associated to AI privacy and governance? Are there detections on it? And are they exposed? We also can expose attack paths for AI ML services. So if models or containers have access to sensitive data, or there are vulnerabilities and exposures that have access to sensitive data, we're able to discover them and give context in terms of how that access is generated. Let's move on to best practices. We spoke a little bit about how you secure in the pipeline, spoke a little bit about how you secure the services themselves, and of course, how you can secure the runtime layer. But that's just one part of a giant strategy that you might want to think about. AI security and strategy involves 5 different areas. We spoke about supply chain governance. This includes things like data governance, whether you're scanning and scanning for the data themselves, traceability of that data, and traceability of any software that's being used. This allows you to ensure that you secure all of the software being built for the application itself. The second part of it is the development lifecycle, which includes things like vulnerability assessments, understanding model governance, and ensuring there's a process where no humans are involved typically, and ML ops takes place in an automated fashion with all of the guardrails in place. The third bit is about transparency and responsibility. Most users are afraid of using AI because they're not sure how what it might emit, what it might, is it biased or not, is it giving the right information. So providing users an ability to understand what data it's trained on, understanding ways to communicate with them, and of course, maintaining records of how the specific training occurred so you can provide visibility and auditability and traceability for governance and regulation. Now, this space is changing quite a bit, and what that means is new attack techniques are being discovered every day. And so investing in some sort of an adversarial R&D team specific to AI technologies is becoming a need for many security teams. It's understanding how to build proactive defensive tools, which means you're monitoring for all of the things we spoke about before the risk occurs, but also doing things like red teaming, understanding if the model is behaving the way it's intended to behave. Is it leaking data? And finally, research into effective guardrails. Guardrails allow to control input-output responses and also can categorize and control how the LLM behaves. And finally, train the SOC team. Of course, you need cyber responsiveness, which means now you need to figure out if your model just did something bad, how do you ensure that you have incident response methodologies in place? If you're under some sort of a DDoS attack for the model itself, how do you have incident response methodologies in place? And of course, any threat intelligence, who's using or trying to abuse the model themselves. Now, all of this is wrapped under specific already in place strategies, including things like access control, securing the cloud services, and zero trust on device and operations. Now, with CrowdStrike, we do work with AWS in plenty of ways. We integrate with many services in terms of both deployment, runtime protection, as well as monitoring all of the services, allowing you to secure the AI application as well. And any integrations that you choose to use are available on that GitHub page. So if you want to take a look at it, there's a QR code there that you can use. So with that, I want to wrap up with some resources that you can also access, including the Global Threat Report. Gives you access to some of the threat intelligence and discoveries we've made over the past year. We ourselves build AI applications for security teams, enabling them to move faster. Call it Charlotte AI if everyone's watched the ads. And of course, if you haven't started using Falcon Cloud Security yet, please go ahead and use it. With that, thank you so much for your time. If you have any questions, I'll be down here and happy to take them.